Let A with the coordinates x1, y1 and B with the coordinates x2, y2 be any two given points in a plane. The vector joining point A to point B is given by vector AB. Now this is what this statement means. We have this point A, so we have our xy plane. Okay. Then we have this point A in the plane and this point B in the plane. The coordinates of point A are x1, y1, and the coordinates of point B are x2, y2. If we join point A to point B, you see that we have created the vector AB, as we can see here. Now, how do we find this vector AB from the coordinates A and coordinates B? This vector AB is given by the position vector of the second point, which is B. So the position vector of B, that's the vector OB, minus the position vector of the first point, which is A, which will give us the vector OA. So if you want to find the vector AB from the coordinates of A and B, is given as the position vector of B, which is the second point, minus the position vector of A, which is the first point. So this is going to give us vector OB minus vector OA. We know that vector OB is the position vector of B, which can be written as small letter b. Vector OA is the position vector of A, which can also be written as small letter a. What are the coordinates of small letter b or position vector of B? The components are the coordinates of the point B. The coordinates of point B are x2, y2. So the component of the position vector B will be x2, y2. The components of the position vector A are the coordinates of the point A. The coordinates of point A are x1, y1. So the components of position vector A will be x1, y1. So you subtract position vector A from position vector B to get the vector AB. So in the same way or similarly, if you have the vector xy, it's the same as position vector y, so OY, the second point, minus position vector x, OX, the first point. So it is always the second point minus the first point. So the position vector of the second point, in this case y, minus the position vector of the first point, in this case x. So if you have something like this, let's say you have the vector df. If you have the vector df, it's going to be vector OF minus vector OD and this will give us position vector F minus position vector D. And we know the coordinates of F, we know the coordinates of D, so we can use it to find the vector DF. In the same way, you have, let's say, something like this, GM. If you have the vector GM, it's going to be, this will give us OM, so it is always the second one, position vector of the second one, minus OG, and this will give us position vector of M minus position vector of G. So as you can see it, you know the coordinates of M, we know the coordinates of G, so we can find the vector GM. So what you have to take note here is that if you have the vector AB and you want to find the components of vector AB from the coordinates of A and B, is going to be position vector of the second one, so here position vector OB, minus position vector of the first point, which is A, so position vector OA. We know the coordinates of position vector B, we know the coordinates of position vector A, so we can find the vector AB. Let's pick some examples and see how to do this. We have 4 questions here. We will solve the first one in this video, then we solve the others in the subsequent videos. So let's pick the first question. Find AB, the vector AB, if the coordinates of point A are 4, 8 and the coordinates of point B are -1, 5. we know that the vector AB is equal to position vector B minus position vector A. That is vector OB minus vector OA. We just explained that. So this is going to give us, we know that OB can also be written as small letter b. You don't necessarily have to write it. I'm just writing this to explain to you. OB can also be written as small letter b minus OA can also be written as small letter a. The components of B, small letter b, that's the position vector B, are the coordinates of point B. So here, the s component of the position vector B is the s coordinate of point B, so -1. The y coordinate of position vector B is the y component of position vector B is the y coordinate of position vector is the y coordinate of point B, so 5. Then you bring your negative sign. When you come to point A, the components of point A will be the coordinates of the components of position vector A will be the coordinates of point A. So the s component of position vector A is the s coordinate of point A, which is 4. The y component of position vector A is the y coordinate of point A, which is 8. So we are going to have -1 minus 4. In the video on addition and subtraction of vectors, we explained how to subtract vectors. So -1 minus 4 give us -5. 5 minus 8 will give us -3. So we have been able to find the vector AB from the coordinates of point A and point B. Find vector PQ. If point P has the coordinates 7, -1, and point Q has the coordinates -4, -3. We know from the previous video that if you have the vector PQ, it means that it's going to be position vector Q minus position vector P. So it's going to be vector OQ minus vector OP, which is the same as position vector Q minus position vector P. We know the coordinates of Q, so it means that the position vector P, the components will be position vector Q, the components will be -4, -3, then minus position vector P. We know the components or the coordinates of P, so the components of position vector P will be 7, -1. We explained this in the previous video. So if you are doing the subtraction, we are going to have -4 minus 7, which is -11. Then we have -3 minus -1, which will give us -2. So we have been able to find the vector PQ from the points P and Q. We are supposed to find vector XY from the points X and Y. We know that vector XY will give us position vector Y minus position vector X. And this is going to be, as we have here, so vector OY minus vector OX, which is the same as position vector Y minus position vector X. As I said, in our examination, you don't have to write this. As soon as you write OY, it means position vector Y. If you write OX, it means position vector X. It's the same thing. So you don't have to write this here. I just bring it to explain it into details for you. Okay, so what are the components of position vector Y? They are the coordinates of point Y, which are 3, 2. The components of position vector X are the coordinates of point X, which are -5, 2. So we have 3, 2 minus -5, 2. So we will have 3 minus -5, which will give us 8. Then 2 minus 2, which will give us 0. So once again, we have been able to find the vector XY from the points X and Y. Let's look at our last question. So we are saying that we have the coordinates of the point P to be 3, 2, and coordinates of point Q is XY. And these are points in a plane, in the XY plane, such that the vector PQ is equal to 5, 6. we should find the coordinates of point Q. So the coordinates of point P are 3, 2, and the coordinates of point Q are x and y. And these points are in the xy plane. We know the xy plane. We have been drawing it a lot since we started studying bearing and vectors. And the vector PQ is 5, 6. Find the coordinates of Q. We know that the vector PQ is equal to the position vector Q minus position vector P. Okay, so vector PQ is equal to position vector Q minus position vector P. We know vector PQ. Vector PQ is 5, 6. We can also find position vector P because we know the coordinates of point P. The coordinates of point P are 3 and 2. So we substitute them into this equation that we've written. So the components of vector PQ are 5 and 6. So 5, 6 is equal to Q is what we are looking for. So Q minus position vector Q minus the coordinates of point P are 3, 2. So the component of position vector P will be 3, 2. Okay, so from here we have to make Q the subject. So I'll keep Q here. Then I'll send 3, 2 from this side to the other side. It's negative here. So when it counts here, we know from linear equations that it becomes positive. So we are going to have 5, 6 plus 3, 2 is equal to position vector Q. So 5 plus 3 will give us 8. 6 plus 2 will give us 8. So it means that the components of position vector Q are 8 and 8. But we know that the components of position vector Q is the same as the coordinates of the point Q. So it means that the coordinates of the point Q will be 8, 8. So you see that with this, we have been able to find the components or the coordinates of point Q. The coordinates of point Q are the same as the components of position vector Q. So the coordinates of point Q are 8 and 8. Let's learn more about a parallelogram. If you have this parallelogram A, B, C, D, as we can see in this diagram, A, B, C, D, you can see that line AB is a vector, so it's indicated here with the arrow. And line DC is also a vector. AD is a vector and BC is also a vector. If this is a parallelogram, then the vector AB is equal to the vector CD and the vector AD is equal to the vector BC. This is a special property of a parallelogram. So if you have a parallelogram like this, vector AB is equal to vector BC. Then vector AD is equal to vector BC. That is what you can see here. So vector AB is equal to vector DC and vector AD is equal to vector BC. With this property, we can find the coordinates of one of the vertices. Let's pick a question and see how to do this. So a parallelogram is shown in the diagram below. So we have this parallelogram here, A, B, C, D. Okay, find the vertex of D. So you see that the vertex D has the coordinates x, y. So you have to find the vertex. What that means is that we need to find x and y. We have the vertex A to be 1, 3. The vertex B as -2, 5. Vertex C is 1, 8. And the vertex D is x, y. How do we find the vertex D? We know that if this is a parallelogram, then vector AD is equal to vector BC. Someone can also say vector AB is equal to vector DC. It's the same thing. I'm using this one. So vector AD is equal to vector BC. But what do we know about vector AD? We know that vector AD is the same as position vector D minus position vector A. We've learned this in the previous video. So vector AD is equal to vector OD minus vector OA, which is the same as position vector D minus position vector A. I'm sure that by this time you are conversant with this. That is why I did not write the OD and OA. So here, when I write small letter D, you know what I'm talking about. When I write small letter A, you know what I'm talking about because you solved a lot of examples. Okay, so the vector AD is the same as position vector D minus position vector A. What are the components of position vector D? The components of position vector D are the coordinates of the point D. The coordinates of point D are x and y. So the components of position vector D are x, y. Minus the components of position vector A are the coordinates of point A. The coordinates of point A are 1 and 3 or 1, 3. So the components of position vector A will be 1, 3. We know that from subtraction of vectors, x minus 1 will give us x minus 1, then y minus 3 will give us y minus 3. So we have been able to find the first part here, which is AD. Let's move on to the second part, BC. Vector BC will give us position vector C or OC minus position vector B or OB. So OC is the same as position vector C or small letter C, as you can see here. Then OB is the same as position vector B or small letter B. The components of C here will be the coordinates of point C, which are 1, 8. So the components are 1 and 8 minus the components of B here will be the coordinates of B, which are minus 2, 5. So if you do the subtraction, you have 1 minus minus 2, which is 3. Then 8 minus 5, which is also 3. So look at something here. We have been able to find AD, and BC. We know that this vector here is equal to this vector here. What did we learn about equal vectors? We learned under equal vectors that if two vectors are equal, then the x-coordinate of the first vector is equal to the x-coordinate of the second vector. So here, x minus 1 will be equal to the x-coordinate of BC, which is 3. And the y-coordinate of the first vector, which is y minus 3, will be equal to the y-coordinate of the second vector, which is 3. We know this from equal vectors, so we can use it to find x and y. We know from equal vectors that because vector AD is equal to vector BC, then x minus 1, y minus 3 is equal to 3, 3, because this is vector AD and this is vector BC. X minus 1 is equal to 3. The x coordinate here is equal to the x coordinate here. You find x, you get 3. The same way, y minus 3 is equal to 3. So the y coordinate in AD will be the same as the y coordinate in BC, or the y coordinate of AD will be the same as the y coordinate of BC. So y minus 3 is equal to y minus 3. We make y the subject and we will get 6. So we have been able to find x, which is 4, and y, which is 6. So we say that the coordinate of point D is 4, 6. So using this the property of parallelograms, we have been able to find the coordinates of point D. The coordinates of the vertices of a parallelogram QRST are Q16, R22, S54, and TXY. Find vector QR, vector TS, and determine the values of x and y. Calculate the magnitude of vector QT. Leave your answer in said form. When you are being given a question like this, it will be very good for you to draw a diagram for the question, and that is exactly what you are going to do. The coordinates of the vectors given us are Q16, R22, X54, and TXY. So we will draw a parallelogram and we name the vertices as we saw in the previous video. The vertices given to us were QRST. So in naming the parallelogram, make sure that the vertices run smoothly around the diagram. Now this is what I mean. You see here, I started from Q. The next one is RST. I could have gone this way, QRST. It doesn't matter where you start from, but make sure that where you start from, the naming of the vertices follows the order that was given to you in the question. So here the order given to us was QRST. So make sure that it goes round, the QRST will go round the diagram. So don't change the order. So it shouldn't be QSRT. You see, when you do that, you have changed the order that the question gave you. That is wrong. In naming it, make sure that it follows the same order as you were given to you in the question. So here, QRST. It doesn't matter where you start from. You have to make sure that you maintain the order. So you can start from here, QRST or QRST. Make sure that you maintain the order. Where you start from doesn't matter. Okay, so we have drawn the diagram for this question. Let's go on and find for the first part. The question says that we should find vector QR and vector TS. From there, we can determine the values of X and Y. So let's begin with vector QR. We know that vector QR is the same as position vector R minus position vector Q. The coordinates of position vector R are the components of position vector R are the coordinates of point R, which is 2, 2. So the components are 2, 2. Minus the components of position vector Q are the coordinates of point Q. The coordinates of point Q are 1 and 6. So the components of position vector Q will be 1 and 6. We have 2 minus 1, which is 1, 2 minus 6, which is -4. So we have found vector QR. Let's find vector TS. Vector TS will give us position vector S minus position vector T. We have explained this in the previous video. So vector TS is equal to position vector S minus position vector T. The second one minus the first one. The component of X will be the coordinates of point X, which are 5, 4, minus the component of T will be the coordinates of point T, which are X, Y. And this we know from algebra that 5 minus X will give us 5 minus X. 4 minus Y will give us 4 minus Y. Now look at something. From the diagram, you can see that QR, vector QR is equal to vector TS. We saw this in the previous video that for a parallelogram, considering this particular parallelogram, vector QR will be the same as vector QTS. So the opposite vectors are the same. So this vector QR here will be equal to this vector QTS. In the same way, vector QT will be the same as vector RS. Okay, but this time we are considering QR and TS. We have been able to find QR and we have been able to find TS. If they are equal, we can equate these two vectors and find the value of X and Y as we did in the previous video. So we are going to equate. We know that QR is equal to TS. So QR is 1 minus 4. TS is 5 minus X, 4 minus Y. So you see that 5 minus X, 4 minus Y is the same as 1 minus 4. From equal vectors, we know that the S component here, which is 5 minus X, is equal to the S component here, which is 1. So 5 minus X is equal to 1. From linear equations, we make S the subject and we find X to be 4. In the same way, 4 minus Y is equal to minus 4. So 4 minus Y is equal to minus 4. We make Y the subject and we find Y to be 8. So we have been able to find X and Y. X and Y are the coordinates of point T. So we say that the coordinates of point T is 4, 8. 4, 8. The question goes on to say that we should calculate the magnitude of vector QT. To calculate the magnitude of vector QT, we first have to find vector QT. Vector QT is equal to position vector T minus position vector Q. The second one minus the first one. Coordinates of T, so components of position vector T are 4, 8. We just found that in the previous slide. And components of position vector Q are 1, 6. So it means that QT, which is T minus Q, is equal to 4, 8 minus 1, 6. 4 minus 1 will give us 3. 8 minus 6 will give us 2. So we now have the components of vector QT. So we can find the magnitude of vector QT. In the video on finding the magnitude of a vector, we said that if you want to find the magnitude of the vector, it's the same as, is equal to square root of the s component, in this case 3 squared, plus the y component, which is 2 squared. So this is going to give us square root of 9 plus 4, which will give us square root of 13. The question said we should leave our answer in set form. In the video on sets, we said that square root of 13 is a set. So you are going to leave your answer like this. You don't know the units here, so square root of 13 units. This is our answer in set form. If vector AB is equal to x, y, the components of vector AB are x and y, then the inverse of vector AB is vector BA. So the inverse of vector AB is vector BA. So if you have a vector and you reverse or you interchange the position of the letters, that one is the inverse of the other. This is what I mean. Let's say we have vector GF. We have vector GF. And we change their position. So we now have vector FG. Vector GF is the inverse of vector FG, or vector FG is the inverse of vector GF. In the same way, if you have the vector PK and you interchange their positions and have vector KP, we say that vector KP is the inverse of vector PK is the inverse of vector KP, or vector KP is the inverse of vector PK. So if you interchange the position of the letters, one is the inverse of the other. How do you find the inverse of a vector? Vector BA, which is the inverse of vector AB, is equal to minus vector AB. So if you have one vector and you want to find its inverse, multiply each component by minus 1. So here, vector BA, which is the inverse of vector AB, is equal to minus times minus vector AB. And this will give us, what are the components of vector AB? XY. So minus XY. So you multiply the S component by minus 1. You multiply the Y component by minus 1. So all that you need to do if you want to find the inverse of a vector is that negate the S component and negate the Y component. So if you have vector AB and you want to find vector BA is equal to negative of the S component, negative of the Y component. That is all. Let's pick some examples. The inverse of a vector is also called its negative vector because you are making it minus. It's called its negative vector. If you find a vector and its inverse have the same magnitude but opposite direction. So if you find the magnitude and direction of a vector and its inverse, you will see that the magnitudes are the same, but the directions will be opposite. We have learned how to find the magnitude and direction of a vector. So you see that if you find the magnitude and direction of a vector and its inverse, they will have the same magnitude, but their directions will be different or opposite. Let's solve these questions. If PQ is equal to minus 3 minus 4, find QP. And if AB is equal to 1 minus 2, find BA. Let's pick the first one. If PQ is equal to minus 3 minus 4, find QP. We know that QP is equal to minus PQ because QP is the inverse of PQ. So we are going to have minus minus 3 minus 4. So we negate the s component, which is already negative. So it is going to be minus 3, which will give us 3. Then we also negate the y component. So minus 4, which will also give us 4. So if PQ is equal to minus 3 minus 4, QP will give us 3, 4. If AB is equal to 1 minus 2, what is BA? We know that BA is equal to minus AB, and this will give us minus 1 minus 2. So we negate the s component. It's positive here, so if you negate it, you are going to have minus 1. Then minus 2, which will give us 2. So it's like we have negative 1 here, and we are using that negative 1 to multiply the s component, and we are using the same negative 1 to multiply the y component. So this will give us minus 1 times 1, which is minus 1, minus 1 times minus 2, which is positive 2. So if you have a vector and you want to find its inverse, all you need to do is to multiply the s component by minus 1 and multiply the y component by minus 1. The new vector that you have is the inverse of the other vector. What is the triangular law of vector addition? If you have these 3 points, points A, B, and C, and we join point A to point B such that we get the vector AB, we join point B to point C such that we get the vector BC, and we join point A to point C such that we get the vector AC. The triangular law of vector addition says that moving from A to C, or vector AC, is equal to vector AB plus vector BC. This is the triangular law of vector addition. If you have these 3 points A, B, C, the triangular law of vector addition says that vector AC is equal to vector AB plus vector BC. Now look at the direction of the arrows and the movement. You see that this arrow moves in this direction. So moving from A to C is equal to moving from A to B, then from B to C. When you have this, we call the vector AC the resultant vector, because that is the result you get when you add vector AB to vector BC. So vector AC here is called the resultant vector. If you add vector AB to vector BC, you get vector AC. So AC is the resultant vector. Note that the endpoint of the first vector should always be the same as the starting point of the second vector before you can add the two vectors. Now this is the meaning of this statement. Vector AB is the first vector that the point is referring to. So the end point of vector AB is B, is the point B, moving from A to B. So the end point is B. The starting point of the second vector must also be B before you can add the two vectors. So the first vector is vector AB. The end point is B. The second vector is vector BC. The starting point is B. So the end point here and the starting point here must all have the same letter before you can add them. Let's see how we can use the triangular law of vector addition to solve some questions. We have 5 questions here. We will take them one after the other. We will solve the first one in this video, and we will solve the others in the subsequent videos. So if PQ is equal to minus 1, 2, if PQ is equal to minus 1, 2, and RQ is equal to minus 3, minus 5, find PR, or vector PR, and the magnitude of vector PR. So I'm going to draw a diagram to represent this question that has been given to us here. The 3 points in question are P, Q, and R. So we have P, Q, R, Q. So the 3 points are P, Q, and R. Now we are looking for vector PR. Because we are looking for vector PR, PR is going to be our resultant vector. So I will indicate on this diagram that PR is the resultant vector. So vector PR is the resultant vector. That is what we are looking for. Now we know that vector PR is equal to vector PQ. So we start from PQ plus vector QR. So moving from P to R, here, PR is equal to moving from P to Q, then from Q to R. So vector PR is equal to vector PQ plus QR. So we can say that vector PR is equal to vector PQ plus QR, as you've seen from the diagram. The question gave us the vector PQ to be -1, 2. But we are looking for vector QR, and we have vector RQ. What the question gave us is vector RQ. We are interested in vector QR. We know that QR is the negative vector of RQ. We learned that in the previous video on negative vectors. We learned that vector QR is equal to the negative of vector RQ, or the inverse of vector RQ. Vector QR is the inverse of vector RQ. So if you have RQ and you want to get QR, we can say that QR is equal to minus RQ. And this is going to be equal to minus RQ is -3, -5. So you negate the S component, but it's already negative. So -3 will give us +3. Then -5 will give us +5. So we have been able to find vector QR from RQ. So vector QR is equal to 3, 5. So we now have PQ. We now have QR. We can find PR. PR is equal to PQ plus QR. PQ is -1, 2. So we have -1, 2 plus QR is 3, 5. So plus 3, 5. So PR is equal to -1 plus 3, which will give us 2, and 2 plus 5, which will give us 7. So the vector PR is equal to 2, 7. The second part of the question says that we should find the magnitude of the vector PR. In the video on finding the magnitude of vectors, we learned that the magnitude of vector PR is equal to square root of the S component squared plus the Y component squared. So 2 squared plus 7 squared. And this will give us square root of 53. If you find square root of 53 on our calculator, we are going to get 3.7 points, then a lot of decimals. We are running this to one decimal place, so it will give us 7.3. We don't know the units here, so we have 7.3 units. If vector AB has the components 5, 6, and vector BC has the components 10, -6, find vector AC and the magnitude of vector AC. So the 3 points in question here are A, B, and C. So I'll use those 3 points to draw a diagram here. So point A, point B, point C. Join A to B, B to C, then A to C to get this triangle. The question says we should find vector AC, which means that is our resultant vector. So on this diagram, I'm going to indicate vector AC as the resultant vector. So this is the resultant vector. Now we know that vector AC, from the triangular law of vector addition, we can say that vector AC, which is the resultant vector, is equal to vector AB plus vector BC. So from the diagram, what we can say is that moving from A to C, or vector AC, is equal to moving from A to B, or vector AB, plus moving from B to C. Okay, so we know from the triangular law of vector addition that AC is equal to AB plus BC. The question gave us AB. and BC. So we can replace AB with 5, 6 and BC with 10 minus 6 in order to find vector AC. AB is 5, 6. BC is 10, negative 6. From the addition of vectors, we will have 5 plus 10, which is 15. 6 plus minus 6, which is 0. So vector AC is 15, 0. The question says that we should find the magnitude of vector AC. In the video on finding the magnitude of a vector, we saw that the magnitude of vector AC is equal to the square root of s component squared plus y component squared. So the s component is 15, so 15 squared plus the y component is 0, so 0 squared. This will give us vector AC, magnitude of vector AC is equal to square root of 225, which will give us 15. So the magnitude of vector AC is equal to 15 units. Let's consider the second question for this video. Vector Tn is equal to negative 2, 2, and vector Mn is equal to 6, negative 5. Vector Mn is equal to 6, negative 5. Find vector Tm and the magnitude of vector Tm. Okay, so in this case too, the 3 points concerned here are T, N, and M. So I'll use those 3 points to draw a diagram or a rectangle here. So the 3 points we are talking about or we are considering here are T, N, and M. So T, M, N, or T, N, M. The vector we are looking for is Tm. So this is the vector we are looking for. We are looking for vector Tm. So that will be our resultant vector. So vector Tm is our resultant vector because that is the vector we are looking for. From the triangular law of vector addition, we can say that this vector Tm is equal to vector Tn. So Tn plus vector Nm. Okay, so vector Tm, this vector here, vector Tm is equal to vector Tn plus vector Nm. So we can say that from the triangular law of vector addition, vector Tm is equal to vector Tn plus vector Nm. The question gave us Tn as negative 2, 2, but it gave us Mn. We are looking for Nm, so we have to find Nm. We know that Nm is equal to minus Mn because Nm is the inverse or the negative vector of Mn. Mn is 6 minus 5. So if you want Mn is 6 minus 5. So if you want Nm, you have to negate the s component and the y component of Mn. And this will give us minus 6, 5. So the vector Nm is equal to minus 6, 5. We know that Tm, vector Tm is equal to vector Tn plus vector Nm. So this is going to be equal to vector Tn is negative 2, 5. Vector Nm is negative 6, 5. From addition of vectors, vector Tm is equal to negative 2 plus minus 6, which will give us minus 8. Then 2 plus 5, which will give us 7. So the vector Tm is minus 8, 7. The question says we should find the magnitude of vector Tm. So magnitude of vector Tm is equal to square root of the s component squared. So it's negative 8. So negative 8 squared plus 7 squared. Once again, don't forget that if you are squaring the negative number, put the negative number in a bracket before you square it. So you are going to have square root of negative 8 squared plus 7 squared. And this will give us square root of 113, which is 10.6 units. So we have also been able to find the vector Tm and the magnitude of vector Tm. Vector St is equal to 5, 2, and vector Tu is equal to negative 1, negative 1. Find vector US and the magnitude of vector US. So the 3 points in this question are S, T, and U. So I'm going to use these 3 points to draw a diagram, or the triangle, sorry. So I'll use these 3 points, S, T, and U, to draw the triangle. The question says that we should find vector US. So that is our resultant vector. So the resultant vector is vector US. This is the resultant vector. We know from the triangular law of vector addition that from this diagram, vector US is equal to vector UT. You start from U, so UT plus vector TS. So we start from U and we end at S. So vector US is equal to vector UT plus vector TS, as we can see from the diagram. Okay, so vector US is equal to vector UT plus vector TS. The question gave us vector ST and vector TU. We are looking for vector UT and vector TS. So we have to find UT and TS from ST and TU. Let's pick the first one, which is UT. We know that vector UT is equal to minus vector TU. And this will give us minus 1 minus 2. So we are going to have minus 1, which is positive 1, minus 1, which is also positive 1. So vector UT is equal to 1, 1. Let's go on to find vector TS. We are looking for vector TS, but the question gave us vector ST. We know that vector TS is equal to minus vector ST. We learned this under inverse or negative vectors. So TS is equal to minus ST. And this will give us minus ST is 5, 2. So we are going to have minus 5. So minus 5 and minus 2. So minus 2. So vector TS is equal to minus 5 minus 2. Vector UT is equal to 1, 1. We have UT, we have TS, so we can find vector US. Vector US is vector UT plus vector TS. Vector UT is 1, 1. Vector TS is minus 5 minus 2. So we are going to have vector US is equal to 1, 1 plus minus 5 minus 2. When we add these two vectors, we are going to have 1 plus minus 5, which is minus 4, and 1 plus minus 2, which is minus 1. So the vector US is minus 4 minus 1. The question says that we should find the magnitude of vector US. The magnitude of vector US is equal to square root of minus 4 squared plus minus 1 squared. Because they are negative numbers, we are going to put them in brackets. If you watch the video on finding the magnitude of a vector, I explained this. This will give us square root of 17. So the magnitude of vector US is equal to 4.1 units. You can also try and find the direction of vector US. I explained that in the video on finding the magnitude and direction of vectors. So you can also try and find the direction of this vector US. Let's take the second question. Vector BD is equal to 2, 3, and vector DN is equal to 5, 7. Find vector BN and the magnitude of vector BN. So the 3 points here are B, D, and N. So I'm going to use these 3 points to draw the triangle. So B, D, and N. The question wants us to find vector Bn. So that is our resultant vector. So vector Bn is our resultant vector. We know from the triangular law of vector addition that vector Bn, which is our resultant vector, is equal to vector Bd. So vector Bd plus vector Dn. Okay, So we can say that from the triangular law of vector addition, vector Bn is equal to vector Bd plus vector Dn. The question gave us vector Bd. It also gave us vector Dn. So you will not have to change anything or find the inverse of any vector. We just substitute them straight away here and find vector Bn. So vector Bn is equal to vector Bd is 2, 3. So 2, 3 plus vector Dn is 5, 7. So 5, 7. So from addition of vectors, we know that this will give us 2 plus 5, which is 7, 3 plus 7, which is 10. So vector Bn is equal to 7, 10. The question says that we should find the magnitude of vector Bn. Magnitude of vector Bn is equal to square root of 7 squared plus 10 squared. This will give us square root of 149. And you have square root of 149 corrected to one decimal place is 12.2. So the magnitude of vector Bn is 12.2 units. Once again, you can try and find the direction of this vector Bn. In the video on finding the magnitude and direction of vectors, I explained how to find the direction of a vector. Thank you for watching this video. This is the end of the topic bearing and vectors. I hope you enjoyed this video and all the videos on bearing and vectors.